is technically section 11, and we're not going to finish all of these parts for today, but we'll continue this on Thursday, and then we'll lead into section 12. Okay, so I'm just going to kind of introduce you guys to parts of multiple linear regression, and just to make sure that runs. Okay, so multiple linear regression, like I said, basically you have multiple features, multiple variables in a target. And so again, you can kind of see how this would probably work better. The only problem with multiple linear regression is that there's multiple features, which means multiple dimensions. So it turns out, I don't know about you guys, but I can't imagine a fifth dimensional line in my world or whatever, right? Is that linear regression is very nice. Usually it'll be presented like these kind of values right here, where it's nice, you know, X and Y, very simple. Sometimes we'll do 3-dimension, but after that, it's kind of hard to show that, right? So I'm just quickly showing you some example code of what this would look like. I'm generating some data. Oh, got a random seed here first. I'm generating some data. In this case, I'm getting 100 points right here. Random form, uniform, doesn't really matter. Okay, and basically I'm using this right here to make a normal curve right here. And I'm just doing some reshaping. So this is just creating data so I can play around with it, right? And you can see, for example, I think this is from curriculum as well. It's been a while since I actually used this. So seniority versus income. So you can see my seniority, as I increase seniority, was my income change. In this case, I fixed the data to be like this. And you can see here, I actually plotted a nice, beautiful line that actually fits right through the center, mostly because I kind of knew what the values were supposed to be, right? But the whole point here is that the data would be come across this. We could observe it, say, what's the R-squared value and all that stuff, and be a good R-squared value and say, cool, end of the day. So again, our target is equal to our slope times feature plus intercept, or y equals mx plus b, or y0 plus y1 times x, or yeah, x. So that's kind of like the idea there. And note that's like, well, we had this like y, you know, w0 plus wx, can't talk, w1 times x1. It's like, we did this, like, there's not a reason why we couldn't like add more features. So if you look at this, if you look at everything to the left of here, you can see that's our linear regression. And now if I start adding some extra terms, for example, I have n different number of features, I can now just keep adding different weights here, different numbers to add this part. So you can imagine having multiple features put together. And this is what we lead into multiple linear regression. So like I kind of told you, kind of mentioned a little bit, is that by having just one extra feature, we end up getting a 3-dimensional part. And it turns out, if you think of like our linear regression using a line to predict the values, for multiple dimensions, we use, like, for, let's say, for 2 features. So you can imagine there's 2 features, one right here, and this z-axis here is my target. This right here would be our 3-dimensional data. It's basically being predicted along a plane, right? Just a sheet of paper. And so as we get into higher, basically more and more features, we get into higher dimensions. This plane becomes into something called a hyperplane. Basically, it means like a flat object, quote unquote, right? Basically equivalent to a plane, but in higher dimensions. So yeah, I don't know about you guys, but I can't visualize past 3 dimensions, and even sometimes I can only visualize in 3 dimensions, which is kind of sad sometimes. I feel like I should be able to do that since I live in a 3-dimensional world. But the point is that our prediction now ends up being in a higher dimensional space and like a hyper plane. So just know basically is that the reason why we call it a hyperplane like this is that we can actually take slices of our hyperplane and say, okay, well, that essentially is a 2-dimensional, one feature, one target. So if you imagine taking kind of like, the way I kind of imagine this is like, if this is my hyperplane in space, right, my hand is, if I look at it straight on, like this direction, I would see like a line here. And then if I look down like at this angle right here, I can't really do this very well, but if you imagine if you look straight down on this angle right here, you would see a line if it was perfectly flat, or a line like this way. So essentially is that we can build this hyperplane out of a bunch of simple linear regressions. And that's essentially what we're doing here, right? Essentially what this equation is kind of like saying, is where I'm trying to get the mathematics and the visuals putting together, is that if we have this y hat and this part right here, it's like we're saying, okay, y hat, and I'm just gonna leave off the intercept y0 just to kind of help my scenario. We can say, okay, let's look at the first one. Oh, that's like w1 times x1, okay? And then the second part's like, well, that's like saying y hat is equal to w2 x2, and so on. I could do this like for w3 x3, all the way to however many features I have. And if I were to add these all up together, I would have it. So one way you can kind of think about this, instead of saying W1 plus W0, it'd be like W1x1 plus some constant, which ends up being like W0 plus all the other features. Okay, basically keeping all the other features constant, this becomes a constant by itself, and you have a little tiny linear regression like this. And then I have this one right here. It's like, well, this one has a different linear regression for this W2. This would be X2. This would still be Y. And I have a different kind of linear regression. So you can basically build these little tiny linear regressions out of one large one. And, or you can think of it the other way. So I can take a bunch of little linear regressions and add them up to make one big linear regression that looks like this guy. Okay. So I think the curriculum kind of shows this little picture, which I kind of like. But basically it's like you can think of like each part just putting a little linear regression. It's like, well, okay, I could predict weight really well based on height. So I have the height and our weight, and I have this kind of prediction. And then maybe I have something that's like, I'm trying to think of something useful, but like, so they, metabolism. There's some way to measure metabolism. And it's going to be some values, right? And as we increase metabolism, our weight goes down. So you might have something like this for its linear regression. And then we can add these two features. So this could be something like, you know, this total linear regression together would be some factor W0 plus, let's say, some value W1 times the height plus some value W2 times the metabolism, whatever the metabolism is represented by. And that would be our multiple linear regression. Okay, but these are just built out of linear regressions. So that's kind of how we're doing this part. So hopefully that makes sense. Thumbs up if that sounded pretty good. Sideways, you're like, I don't really understand what you're saying. Thumbs down, you're like, multiple dimensions, I don't get this. Okay, cool. So I see some kind of sideways, mostly up. Okay. My goal is not to confuse you too badly, right? But confuse you just enough for you to like question your reality or something like that. Okay. So let's see, I have 5 minutes. I'm trying to debate if I want to talk about this. So, okay, I am going to talk about this briefly. We're probably going to review a little bit on Thursday just to kind of refresh you guys. But one thing we've only been looking at is if values increase. As you increase the height, your weight will go up, right? But clearly there's some factors, for example, if you're male or female, right? Which you're either male or you're female in this case. You might have multiple genders in this case, but we'll stick it simple, basically like you're assigned sex, male and female, right? So if we just had two categories like this, we'd have to consider, say, well, okay, well, how do we do linear regression? Essentially, and this is the part that I think is kind of missed on for the curriculum, and I think in general, is that, remember how I said like all of our different features are basically little linear regression lines? Essentially, when you have a category, what we'll have is something like, you know, let's say y hat, and I'm going to use our weight example again. So y hat is our weight prediction. And we have some factor W0, which is just like the initial weight. Basically, you can't be less than this weight, right? So that's kind of like that W0. We have our W1 times the height. And then we have something like W2 times the other feature. In this case, it's going to be, I'll just put gender. I don't know how to put gender. We'll put G, okay? So we'll just say gender. And we'll say simply just male or female, just to keep it simple so I don't have to consider all the different categories. But you can have multiple categories, just know this. Is that basically you can say, okay, if you're male, you are not a male or you are a female. Okay, those are your two different categories. Well, we can represent that essentially as a 0 or a 1, right? So essentially you say, okay, like you are either a male, which is 0, or you're a female, which is 1, okay? And what this essentially does, it creates two linear regression lines for you. So you might have essentially like, I'm gonna kind of draw this out, is that let's say the data points look like this for female, and then for male, yeah, I'm doing blue and pink. I know. So blue basically for male, pink being for female, okay? And so basically it's like, okay, you might essentially have two different lines. So your first initial line, let's say it's just this guy right here. So if male is 0, right, and you're male, basically this part disappears and you essentially just have a linear regression line that looks like this, okay? If you are female, instead of being added to 0, basically just this guy, instead you get added to just like a W2 factor. And let's say this factor is negative or something like that, right? So in that case, you basically drop the line downward right? You decrease this y-intercept, and essentially you have a new linear regression line. And all it is basically, it's the same, it's all parallel, but it's just being shifted upwards or downwards. And that's what's going on with a category here. Essentially, you're just saying, oh, let's give it a boost factor, or I don't know, what opposite of a boost? An anti-boost factor, okay? So it's dropping it down or it's raising it up. And that's all we're essentially doing with a category. And note that we can have multiple categories. So if I wanted, mostly like if we had something called, well, if we had like, let's say multiple genders, right? Or something like that, or something where we had multiple categories, you might have essentially each category saying, oh, are you male? Are you female? Are you something else? Are you, you know, whatever category. And this one right here, we have examples of like different cars. You might have to say, oh, are you a truck? Are you, I don't know, a little economic car? Are you a bus, right? In that case, you would just say, are you a bus? Yes or no, 0 or 1. Are you a car? Yes or no, 0 or 1, okay? And that basically changes how much the line goes up and down, okay? And that's what category value is. But we'll talk about this again and how we actually pull this information out to use in a multiple linear regression line, okay? Any general questions about anything I talked about before I kind of end it from here?
Categorical, it's always parallel, the difference?
Yeah, you can think of it like if everything else is exactly the same, all you're doing is adjusting that line up or down. So essentially everything's the same. So essentially you have it parallel in that way, if that makes sense. Yeah. I'm trying to think of like if I'm wrong in this, but I think for linear regression in this sense, all we're doing is essentially adding an extra factor or subtracting an extra factor, keeping everything the same. Okay. There's other ways we can do it. For example, in module 2, we'll talk about advances or changes to linear regression. And you might have, for example, like it being multiplied, multiple features being multiplied together. In that case, that doesn't necessarily have a parallel adjustment. But this is the simplest model. And surprisingly, multiple linear regression does a pretty good job without even having to do really too much to it. Good question, Andrew. All right. Any other questions? Cool. All right, so I'm going to go ahead and stop my recording from here.